So our learning target, I can solve linear equations with multiple steps using distributive property and combining like terms before I solve. So you're taking everything that we've done from our first unit, where we learned how to distribute and we learned how to combine like terms, and you're simplifying your expressions down so that way you can get them into that two-step equation format. Remember, when we're looking for a two-step equation format, we are looking for something that's in the format of A times X, where X is a variable, and then it's going to be plus or minus B, and it's all going to be equal to some value C. Okay, A, B, and C are all number values. That's the goal. We want to get this long equation to look like this, where we have a single value for a coefficient with a single term of X. We are adding or subtracting a single value, and then we're setting it equal to a single value. We do not want to have all of this here. So we need to work on simplifying first. You always simplify your expressions. So an equation is just two expressions that are set equal to each other. So we are trying to simplify our expressions first, and then we're going to solve. You simplify, or you do before you can undo. So our first step when we are simplifying is to always look and see if there's any distributive property that we can do. So remember, if there is distributive property, then that means that we have parentheses with a binomial or a trinomial or some kind of polynomial inside of the parentheses, and we've got a value that we can multiply or distribute to that expression. So in this case, we can multiply -4. Remember that minus sign acts like a negative sign. We can multiply -4 to the term 3x. We can also multiply -4 to the term -6. So both of those terms are going to change. We are focusing on doing -4 times 3x and -4 times -6. That's our first focus. Okay, so -4 times 3x comes out to a -12x, and -4 times -6 comes out to a +24. I'm going to write the positive sign because remember, this is not just a number as my final answer. I'm putting it into an expression. So I am going to write a +24 so that I now have -12x plus 24 here. But I'm not done because there's all of this other information that did not get distributive property. So that means we're going to bring it down into the expression. Everything that was not used just comes down like so. So we put 9x in front of this distributed term. We still bring in our equal sign, and then -3 plus 18 never changed. Okay, so we've done our distributive property. That was the very first step that we had to do. We can then move on to where we can combine like terms, and we focus on like terms for each side. Okay, so when I'm talking about like terms, my first thing I'm going to focus on is any like terms that I can combine together on just the left side first. So any like terms that I can combine together on the left side of my equation. So when we're talking about left sides, we're talking about our equal sign. Our equal sign is like a barrier between two sides. So we're looking at just the left side. Is there anything that we can combine together here? Nathan? Good. We can combine together this 9x minus this 12x. That information can be simplified. So if we were to do 9x minus 12x, that's going to give us -3x. Now, we still have a plus 24 that cannot be simplified with anything, so I'm just going to bring it down. And it's set equal to my right side, -3 plus the 18. Okay, so I have simplified the left side of my equation as far as I can. -3x plus 24 is as simplified as it's going to get. So now we can go to step 3. which is to focus on the right side of our equation. So on the right side of the equal sign, can we combine or simplify this? Yeah, right? They're both numbers. They can be combined together. It does not matter that one's positive and one's negative. We can actually combine that information together. Okay, so we can do negative 3 plus 18. What is negative 3 plus 18? 15. Okay, so this is going to be equal to a positive 15. Do I have to write the plus sign here? No, because there's nothing else within that side of the expression. If I cover this up, there's nothing else in here on this side that's going to belong with that 15. I'm not adding it with anything. I'm not subtracting it with anything. It's not being combined together with any variables. It's just a 15. So in a situation like this, when that's the only term left in that part of the expression, you don't have to write the positive sign. Okay? So we bring down the rest of our expression. We still have our equal sign that's separating our sides, and we have that negative 3x plus 24. So now we are down to a two-step equation. So I'm going to rewrite that whole two-step equation right here. Negative 3x plus 24 is equal to 15. I then can follow my two-step equation format. The very first thing that we always do for two-step equations is we focus on getting rid of that constant. Now, I had one student yesterday who said, but there's two constants. They said 24 is a constant, but so is 15. So which constant am I talking about then? If I'm trying to focus on isolation, which constant am I moving? Am I getting rid of? Jeremy? 24. The reason we're focusing on 24 is because we're focusing on isolating our variable. We want to isolate our lettered term so that it's just that value by itself. So that means everything that's around it or on the same side as that variable needs to be moved to the other side. Okay? So for here, we are focusing on just the 24. So I'm going to put a box around my 24 so that I know that I'm focusing on the inverse operation to a plus 24. What was the inverse to plus 24? Minus 24. Okay, so we're just going to subtract 24, and to keep it balanced, we're doing it to the other side as well. So these 24s are going to go ahead and get crossed off. I'm not going to cross off 15 and 24 though, because they're not going to get rid of each other. They're just going to simplify to something new. What is 15 minus 24? Negative 9. Negative 9. So we have negative 9 on the right side. What do we still have remaining on the left side? A negative 3x. That negative 3x is still a part of this side. Right? So now we're down to just one of those one-step equations. Negative 3x is equal to negative 9. So with our one-step equations, all we're doing is using either multiplication or division to get rid of what other value. It might be a coefficient, it might be a divisor, but it's physically attached to our variable. Now, I had a lot of students yesterday go, oh, well, it's a negative 3, so I need to add 3. But this is not subtraction occurring here. This is multiplication. When they are side by side, that is a multiplication problem. You're just multiplying by a negative. So your inverse operation is always going to be division. Okay? When you are multiplying or dividing, you multiply or divide by the exact value. If the value is positive, then you're multiplying or dividing by a positive. If the value is negative, you're multiplying or dividing by a negative. So please don't change the signs. So we're going to divide both sides here by negative 3. X is now going to be isolated because negative 3 over negative 3 is a positive 1. So we get x is now equal, and what's negative 9 divided by negative 3? 3, positive 3. And guys, I know it's a lot of work, but the beautiful thing about algebra with equations is you can plug it back in to check. You can take your answer And you can substitute it right back into this long expression and see if it equals what this side would equal. Okay, so I can do 9 times 3 minus 4, and then parentheses, 3 times 3 minus 6, close parentheses. I can type all of that directly into my calculator as I see it. So here I'll even show you. Okay, it says 9, and then we're going to do times 3, and then we're going to do a minus 4, and then parentheses. It's going to be a 3 times 3, and then a minus 6, and close parentheses. So all I did was substitute in everywhere where I see an X, I substituted it in as times 3. Okay? So once I'm done with that, and then I hit my enter, I get 15. So now all I have to do is check, is negative 3 plus 18 going to give me a 15? Yeah. So I know that I've done the question correctly. If you substitute your solution back into the original equation and it did not come out true, then you know you made a mistake. Okay, so you always want to make sure that, take your time, double check. That took me 10 seconds to plug it back in to see if it was correct, right? So one more time. First step, we're always going to look to see if we can distribute. Are we always going to have distributive property? No, because like here, problem number 1, is there distributive property here? No. So it says if possible. If possible, distributive property will always be first. If you don't have distributive property, you move to your next 2 steps. Step 2 and step 3 essentially are the same. You're combining like terms. You're just doing it, combining it on one side and combining like terms on the other side. Once you've done that, you should have it down to either a 2-step equation or a 1-step equation. And then you solve. Okay, so when we're taking a look at problem number 1, we've got 4n minus 2n is equal to 4. We already just discussed we don't have any distributive property there. So now we're going to focus on combining like terms. So I'm going to cover up my right side and just focus on the left side. Can I combine like terms here? Yeah, because they're both variable terms of n, right, to the same power. So I can combine my like terms for 4n minus 2n. What is that going to give us? When we do 4n minus 2n, we're going to get 2n. Good. So I'm going to write that down. I get a 2n. Okay, I've simplified that side as much as I can. So now I'm going to cover up this side. Can I simplify this any further? No, I cannot simplify the 4 any further. That 4 is just going to be equals 4. It's just going to stay as an equal 4. All right, is it a 2-step equation? Is this 2 steps? No. Remember, 2-step looks like this, doesn't it? 2-step looks like this format where we have multiplication or division with our variable, and we have either addition or subtraction with a constant. Do we have a constant in this problem? No, not on this side. We don't have a constant on this side. So it's just a single-step equation. 2n, or 2 times n, is equal to 4. What is the inverse operation that we will need to solve? Ava? Division. Okay, and what are we going to divide both sides by? Nathan? 2. Okay, I had some students yesterday who were getting a little confused with the delta math when it came out to where you were taking a small number and dividing by a large number. I think you guys have gotten it ingrained that you always have to do a larger value divided by a smaller value. But yesterday you learned it's not always the case, right? Sometimes you're going to have a fraction for your answer. Or sometimes even when you do divide a big number by a small number, it's still going to stay a fraction answer. So you have to get used to the fact that division is just fractions. That's why when I write my division here, you don't see me putting a little division sign, do you? Am I writing that? No, I'm writing a fraction bar so that you guys get used to the idea that you're just doing a fraction. Sometimes a fraction can simplify to a whole number. Sometimes the fraction is going to stay a fraction. And improper fractions are perfectly fine because you're going to see towards the end of the semester and then in the beginning of next semester, we're going to keep our fractions improper because we're going to be using them to graph. Remember I told you guys that these are called linear equations? And that when it's a linear equation, if we graph it, it looks like a what? A line, right? Linear, think linear, has that line inside of the word. When we graph it, it's going to be a line, okay? So when we have sometimes an improper fraction, those improper fractions with a variable creates the line for us. It's called a slope. So we're going to learn a lot more about that stuff towards the end of the semester, but I want to make sure you understand all of this ties in. Okay? So we're going to divide both sides by 2. The 2's, remember, they don't cancel out. Cancel out means you've got a 0. They don't cancel. What do they simplify to? 1n, right? Do we have to write the 1? No. Remember our invisible math board. You don't have to write the 1. You can just put n. But the goal is to get it to be a positive 1 coefficient. Okay, and then 4 divided by 2 is 2. Okay, let's take a look at number 2. It's a little bit more detailed, but not that much. Do we have any distributive property? No. We know we don't have it because there's no parentheses, right? So no distributive property. Okay, let's combine like terms. We're always going to focus on the left side first. So I'm going to cover up my right side. Can I simplify this at all? No. Negative 12 is as simplified as it's going to get. So I'm just going to go ahead and bring that down. Now I'm going to cover up the left side. I'm going to focus on this right side. Are there any like terms that I can combine here? Yeah. What can I combine? 5v and 2v. Good. And it's a positive 5v and a positive 2v. I know that they're both positive because of the plus sign that's in front of both of them. Okay? So I can combine the positive 5v and a positive 2v, and what am I going to get? 7v. Am I just going to write 7v? No. What's missing from it, Jeremy? What else do I need to write with it? Huh? The 2. Okay. Am I done? Daniel? I have to add the positive. Why do I have to put the positive sign in front of that 7v? Because I'm still adding, right? There is still a number that's happening here, right? We still have another part of this problem, so we have to show that there is an operation that's occurring. Okay, if it was a negative, I would have written the negative sign, and that negative sign would then act like a subtraction sign. So you want to make sure you're getting used to writing your signs, even when it is a positive, because when you start bringing things down, that positive sign is going to act like a plus. All right, we've simplified. We're now down to a 2-step equation. What do I do first? Eli. Cancel out the 2. How do I do that? I don't know what cancel out means. What am I going to do? Rethink. What's the inverse operation for the 2 going to be? Minus 2. Right? And is it minus 2 because of this plus sign? No. It's minus 2 because what's imaginary in front of that 2? A plus sign. Right? We have an imaginary plus sign in front of it. Remember, this plus sign that I have in purple belongs to the 7v. That's why I went ahead and wrote it in purple, so that you would remember it doesn't belong to the 2. It belongs to the value or the term that it's in front of. Okay? So had this been a subtraction sign instead of a plus sign, I would still be doing the inverse operation to the positive 2. Okay? So be very mindful of that. We have a positive 2. We're going to subtract 2. Where else am I subtracting 2 from? John? On the negative 12. See, I have a lot of students yesterday, when they see equations written this way, they automatically think that they have to still keep going to the right. But this is just written in a backward format, isn't it? It's okay. You're always focusing on doing what is the opposite to both sides of your equal sign. Okay, so we're doing a minus 2 to the negative 12. Now I can go ahead and box off my 2's. What am I going to get? What am I left with here? What's negative 12 minus 2 going to give us? Tanner. Negative 14. And then what do I bring down on this side? 7, right? Positive 7v. Do I have to write the positive sign anymore? No. I would only have to write it if it was a negative sign or a minus sign. I don't have to write the positive sign. So I'm just going to put 7v. All right. Hayden, What do we do next? I know, that's why I called on you. What are we going to do next? Put your hands down. I'm waiting on Hayden. He's going to tell me what to do. And what are we going to divide by? Yeah, we're going to divide both sides by 7. When in doubt, you're always focusing on the numbers that are with the same side as the variable. Okay? When in doubt, always dividing or multiplying by the same number that's connected to your variable. So we're going to divide both sides by 7. Okay? Negative 14 divided by 7? Negative 2. I could write negative 2 is equal to v. I usually like to write v is equal to negative 2, though. I like to always put my variable written first. But if you write negative 2 is equal to v, it's perfectly fine. Any questions? Let's see here. All right. Let's go ahead and flip it to the next page. I think I'm going to let you guys tell me which problem on here you would like me to do an example of still. I figured. I was thinking 8, but I figured you guys would want it because it's the longest looking one, right? It's actually not the most difficult, though. All right. So one thing I want to make sure you understand. Yes, I know that there's a fraction here, but you're still going to wind up getting a whole number answer.
Okay, cool.
So it's not gonna hurt you in the long run. You will get a whole number answer. You will have a fraction to deal with in the middle of the equation, but you're gonna get a whole number answer. I am gonna do number 8 because number 8 is the longest one. Taking a look at number 8, what do I need to do first? Distribute, right? We do see distributive property here. We've got those parentheses. So we are going to focus on doing 3 times 4x, which is going to give us 12x. And then we're also going to multiply 3 times negative 5. So 3 times negative 5 is going to give us negative 15. Okay, so I've done my distributive property. I'm still going to bring down the rest of the problem. So this negative 4x and this plus 1 comes down, and then it equals negative 6. Okay, so now the beautiful thing about you just simplifying, oh, I know I told you, hey, step 2 is to simplify just the left side, and then step 3 is to simplify the right side. You can simplify all together at the same time. I can cover up here, simplify, cover up here, and simplify if need be. I don't have to write multiple lines for simplifying. Does that make sense? Okay, so I just want you to know it's just that simplifying the left side is one thing that you're doing. Simplifying the right side is another thing that you're doing. You're not simplifying them together. Okay, what stays on the left stays on the left. What's on the right stays on the right. Okay, so taking a look at the left side, can I simplify anything here? Yeah, 12x and what? Negative 4x. Who said negative? Good job, Ava. Negative 4x. So we've got 12x and negative 4x that can be simplified. So if I do 12x minus 4x, that's going to come out to 8x. All right, so I've simplified that. Is there anything else I can simplify?
Negative 15 and positive.
Negative 15 and positive 1. So I'm going to just go ahead and underline them because I'm keeping them in the same color. So I'm going to just underline that I'm going to combine those together. So I've got a negative 15 and a positive 1 that can be combined together. to give me negative 14. Negative 14. Okay? So I've combined everything I can on the left side. What about the right side? Can I combine anything there? No. So it's just going to stay an equal 6. Or, sorry, equal negative 6. All right. Two-step equation. Two-step equation. What is the first operation that needs to be done, Daniel? Huh? And which is that? It's always inverse operations. Adding. And what are we adding to both sides? 14. Very good. We're always doing inverse operations when we start solving. I just need to know what is the inverse operation. And don't just tell me, oh, we're adding. Tell me what it is that you're adding to both sides. Okay? So that's going to give us an 8x, bless you, by the way, is now equal to a positive 8. And then our last step, Ava? Divide both sides by 8. Not because of this 8, but because of the 8 that's connected to the variable. That's the reason we're dividing by the 8s. And we'll get x is equal to a positive 1. Bless you. X is equal to positive 1. Okay, so your assignment for tonight. Your assignment for tonight is to just complete these problems. That's all. We're going to go over them in class. It's not a graded assignment, so we'll go over it anyway, but it would be a good idea for you to try it.